Think about how frustrated you get trying to assemble a flat-pack bookshelf from IKEA. Now imagine building a war machine by hand that could outrun boats we use today, with zero blueprints and zero power tools. These weren't just boats. They were the Ferraris of the Dark Ages, capable of hitting speeds over 30 kilometers an hour without a single drop of gasoline. No engine, no GPS, no steel, just raw timber, twisted rope, and a design so advanced it makes modern sailors look like amateurs. That is exactly what the Vikings did more than 1,000 years ago, and their engineering was so terrifyingly perfect that it didn't just change history, it shattered it. How did a group of axe-wielding warriors, often dismissed as barbarians, design a vessel that could outpace today's million-dollar marine technology? The answer lies in a combination of physics and pure audacity that turned a pile of oak planks into the most feared object on the Atlantic Ocean. At first glance, a Viking longship looks basic, a wooden canoe on steroids. But step closer, and you realize it transforms into something completely different. It wasn't built to just float, it was built to hunt, moving silently across the water like a predator stalking its prey before the first alarm could even be sounded. This ship was a weapon of mass disruption, designed to move fast, strike silently, and vanish before enemies could even put on their pants. But to understand how it worked, you have to look underneath the water, where the real magic and the real horror was hiding. The secret to their stealth was a design feature engineers now call low freeboard, meaning the ship sat dangerously low in the water. This low profile made the longship almost invisible from a distance, allowing 40 screaming warriors to hide behind the curvature of the waves until they were practically on the beach. It moved like a shadow across the sea, disappearing into fog banks and slipping through coastal defenses that would spot a taller mast miles away. The hull itself was razor sharp, designed not to bounce over waves like a clumsy modern speedboat, but to slice directly through them. Today's naval architects call this a wave-piercing hull, a feature that gave Vikings insane speed and stability, even in the violent storms of the North Atlantic. Instead of fighting the ocean, the ship worked with it, cutting resistance to near zero and allowing the crew to maintain attack speed when other ships would be forced to seek shelter. The design was also perfectly symmetrical. The front and back were identical, which solved a massive tactical problem. Turning a 20-meter boat takes time, and time gets you killed. So if Vikings needed to escape, they didn't turn around. They just reversed the oars and rowed backward, instantly transforming a retreat into a tactical withdrawal. And underneath it all was the keel, a solid oak spine running the length of the ship that acted like a tightrope walker's pole. It kept the ship upright in gale-force winds, but the real engine of this beast wasn't wood or wind. It was raw human horsepower. The sail was a massive square sheet of wool, treated with horse fat to repel water, mounted dead center. Unlike other ancient sailors who were slaves to the wind direction, Vikings figured out how to angle this sail to catch crosswinds, allowing them to zigzag against the breeze and travel in almost any direction they pleased. But when the wind died, the muscle took over. Inside the hull, up to 30 warriors sat along each side, rowing in perfect, terrifying synchronization. This human engine could generate around 15 horsepower, enough to propel the ship at attack speeds that left coastal guards paralyzed with fear. And speaking of fear, let's talk about the hood ornament. Many ships famously mounted carved dragon heads at the prow, but these weren't just for decoration or branding. They were spiritual countermeasures meant to scare off the landvetter, land spirits of the enemy coast, and protect the crew from the monsters of the deep. According to Norse myth, a cursed voyage wasn't just bad luck, it was a divine punishment from Thor himself. Imagine standing on an English beach at sunrise, seeing a silent silhouette emerge from the mist with a dragon staring you down and the sound of oars beating like war drums. You wouldn't fight, you would run. But the fear factor was just the psychological warfare. The physical reality was even more impressive. These ships could carry 40 fully armed berserkers and still move faster than ships with engines. How? The answer is hiding in the microscopic details of the hull construction. Here is the statistic that still blows modern minds. Viking longships could reach top speeds of up to 17 knots. To put that in perspective, that is over 30 kilometers an hour, a speed that most modern recreational sailboats struggle to hit even with carbon fiber hulls and computer-designed sails. Even early steamships in the 19th century had trouble keeping up with that pace. This wasn't a fluke, it was verified in 2007 when a full-scale replica called the Sea Stallion hit 12 knots in testing, confirming the sagas weren't just bragging. They weren't just fast, they were light, which meant they accelerated like a sports car rather than a bus. This lightweight construction allowed for sharper turns and immediate responsiveness, giving the Vikings a tactical agility that heavy, clumsy European cogs simply couldn't match. That shallow hull didn't just let them sneak through rivers, it drastically reduced drag in the open ocean, letting them glide effortlessly while other navies got bogged down by their own weight. The Vikings weren't trying to set speed records for trophies, they were trying to get to the loot and get home before they died. In the sagas, their ships were described as serpents that cut through the sea, a poetic description for a terrifying reality. But speed is useless if your boat falls apart in a storm. What they did to the planks of the hull feels like something out of science fiction. Out at sea, you don't get second chances. If a storm hits and your boat is rigid, it snaps in half and everyone drowns. The Vikings solved this with a technique called clinker building, where planks overlapped like fish scales, riveted together to create a flexible, watertight skin. Each plank was hand-split from green oak, not sawed, which preserved the natural grain of the wood, making it thin, light, but incredibly tough. This overlapping design allowed the entire hull to twist and flex with the waves rather than smashing against them. It was like giving the ship a suspension system. Modern engineers call this dynamic hull efficiency, and it meant the ship absorbed the violent energy of the ocean instead of fighting it, keeping the crew safe when 10-meter swells were crashing over the bow. The whole ship was strong enough to survive a voyage to America, yet light enough that a 20-meter warship weighed less than your modern SUV. The balance was perfectly tuned. The shape, the weight, the flexibility, it all worked together like a single organic muscle slicing through the water. All of this was built with no blueprints, no CAD software, and no industrial machines. Just knowledge passed down from father to son, and tools as simple as axes and augers. But the most insane capability of this ship wasn't what it did in the water. It was what it could do when the water ran out. The shallow draft is the feature that feels like cheating. Most warships of the time needed deep harbors to dock, limiting where they could attack. Viking ships drew only about 3 feet of water, meaning they could float in a depth barely deeper than your bathtub, opening up literally every river, estuary, and beach in Europe to invasion. This capability meant that no one was safe. Vikings could sail up a narrow creek, raid a farm 50 miles inland, and vanish before the king's army even put their boots on. This versatility gave the Vikings unparalleled options. They could be trading peaceful furs across the North Sea one month, and then terrorizing a monastery on a French river the next, using the same vessel. By the time anyone knew where they were already somewhere else. This is how they reached the Volga River in Russia, the Black Sea, and even the markets of Baghdad. And yes, this is how Leif Erikson reached Newfoundland around the year 1000 AD, beating Columbus by half a millennium, and managing to return home to tell the tale. But sometimes even 3 feet of water wasn't enough. Sometimes the river dried up, or a waterfall blocked the path. Most navies would turn back. The Vikings? They just picked the boat up and kept going, that's right. They carried their warships. When the river ended, the crew would jump out, place logs under the keel, and roll the entire ship overland for kilometers to the next body of water. We are talking about 30 to 40 men moving in perfect sync, dragging a warship through forests and over hills. It wasn't just clever, it was terrifyingly dedicated. Imagine living in a quiet village 10 kilometers from the coast, thinking you are safe, only to hear a rhythmic thumping in the woods and see a dragon-headed ship rolling out of the trees. This wasn't a one-off stunt. They built entire trade routes across Eastern Europe this way, portaging ships between river systems to connect the Baltic Sea to the Black Sea. They treated the continent like a highway system where land was just a temporary speed bump between waterways. If the sea got in their way, they sailed it. If the land got in the way, they walked over it. This amphibious capability is why modern special forces, like the Navy SEALs, still study Viking hull designs for their fast assault craft. Viking ships didn't disappear with the Middle Ages, they evolved. The principles of shallow draft, narrow hull, and low profile are still the gold standard for stealth naval warfare today. But if dragging a ship through a forest sounds insane, wait until you hear what they built when they finally got home. The Vikings weren't just destroyers. They were master builders who could construct a fortress as quickly as they could burn one down. Their expertise in woodcraft didn't end at the shoreline. It extended to their homes, which were marvels of insulation and durability, built to withstand the same brutal winters as their ships. We are talking about full Viking houses built by hand, with no nails, in under 8 hours. Imagine applying that same efficiency, speed, strength, and raw material mastery to building a shelter that could keep you alive in the frozen tundra. If you think their ships were impressive, wait until you see how they turned a pile of logs and dirt into a warm, indestructible home before the sun even set. It is the ultimate survival skill, and I know you want to see exactly how they pulled it off. So, if you are ready to trade the open ocean for a warm fire and see the other side of Viking engineering, just click this video right here. We are going to build a house Viking style.